Hi guys, let's go over the empirical rule. So this here is kind of the last thing that we really need to go over for the, what is it called, for week one. So we don't always have time to get exact information out, and so what we do is we have an empirical rule with which we can quickly evaluate what data roughly looks like. So I'm going to draw you out a gigantic normal distribution here. Because all we're going to need is this one. Oh man, that is terrible. Terrible. Great. So this here's our normal distribution. I'll just put units here because we don't know what they are. And this here is, does anyone know? It is our mean, our bar x, or our mu, if we're dealing with population. Cool. So what is the empirical rule? Well, the empirical rule determines the number of standard deviations, or the distance, it determines the proportion of values in the data set that fall within a given standard deviation. So we have one here. What's that? One here. One here. And one here, and one here, and one here. So the empirical rule determines the proportion of dataset values that fall within a standard deviation. Now this isn't exact, it is an estimate, and that's why we have it. So you could represent this as 0, let me do this in another color actually. You can represent this as 0 standard deviations. And this as 1, or plus 1, standard deviations. This would be plus 2, standard deviations. And this would be plus 3, standard deviations. Oh, that was just the worst. I think that was the worst three-letter word that has ever existed. Deviations. 3 wasn't very good either. You could say that this is minus 1, standard deviations. And minus 2 and minus 3 standard deviations. While I'm catching up, have a Google at the word STD. So you could say that this is the range of standard deviations. Well, one of the things that's important about a normal distribution, and it's going to be something that's drilled into your head by the end of statistics, you won't be able to forget it, is the proportion which is encompassed between standard deviations. So, what we want to know is what percentage of the data falls within what what percentage of the data falls between plus or minus 1 standard deviation. Well, the empirical rule would say that 68% of data falls within this range. So what we can say is that we expect that 68% of data is between this value here and this value here. Now let's go with another color here. So what about when we plus or minus 2 standard deviations? Well, it can't be equal to 68, right? It's much larger. You'll notice that the gap between this and this is far greater than the gap between this and this. So intuitively we would say that it's larger. And it is, you'd be correct to say that. So what proportion of the data is represented here? Well, the empirical rule says that it's 95%. And these are often pretty accurate estimates when dealing with normal distributions. Let's go with one final one. Let's go with a nice teal. Well, what do we do when it's plus or minus 3 standard deviations? Well, obviously again, it's even larger. I'm not going to shade it all in, but while it's even larger, what we say is that there's 99.7% of data that falls between -3 standard deviations and +3 standard deviations. Now this can give you some interesting information. So let's just go with what's a good color? I'll go black, I guess, because I just want to show. Well, what if we wanted to know how much is just in this bit? Well, we could take our empirical rule and we could say, well, 68 equals plus or minus 1 standard deviation, but we're only going for minus 1 standard deviation. So we would expect that it's half of this. So we would divide it by 2, and we would see that 34% of data falls within this. Now what about all of this? Well, because we're talking about the left side of a symmetric distribution, hopefully this will click in your head real quickly. If you're looking at all of the values, well, then it must be equal to 50%. And you can use these values to figure out any combination of the remaining values. So for example, if you wanted to do plus minus 2 standard deviations plus 3 standard deviations. So we're just going to, by this I'm meaning we're taking the range of negative 2 standard deviations, so this one here, and we're going all the way across to here, to the 3 standard deviations. Well, what is that going to be equal to? Well, it's 95% plus 99.7 minus 95, which is the value of these two. Or maybe I'll do that in another color. Which is the value of this, and then we're going to divide it by 2, because we're only looking at this one. Well, what is that? Let me quickly get out my calculator. Someone can beat me to it. You can pause the video though, it's not really fair, it's a time travel. 95 divided by 2, which is 2.35 plus 95. So what we would see is that if we were trying to figure out the range of values between negative 2 standard deviation and positive 3 standard deviations, we would say that 97.35% of values we would expect to fall within this range. We'd expect to fall within this range. And that's how you go over it. That's the empirical rule. It's pretty simple. Just keep practicing.